I'll recognize myself for questions, and Dr. Schmitt, let me address the first one to you. You set some great, worthy goals, landing again on the moon in, I think, 2025, landing on Mars in 2040, only 25 years from now. What does NASA need to do that it is not doing now to get to Mars by 2040 and land astronauts on that surface?
I think Mr. Chairman, I think the main demand to accomplish that would be to put together a management system in NASA that is comparable to what ultimately evolved for Apollo. That system would include an average age that's younger than NASA today. Young people provide that courage and patriotism and imagination that really made Apollo possible. During the Apollo 13 crisis, Gene Kranz did a survey when he had a moment of the ages of people in mission control, and the average age at that time was 26. The nuclear Navy keeps itself young. And it's well worth, I think, looking on how that's done. Of course, it's a military program, and they have different rules than the civil service. But still, I think it's important for the long-term future of NASA to find a way in which it can keep itself young.
Okay, good. Thank you.
That's one of many, but management is going to be the key, I think.
Thank you. General Stafford, just to take it to the shorter term, say the next 4 or 8 years, what recommendations do you have for Congress and NASA as to what we can accomplish in that time frame? And let me add that yesterday NASA announced, I don't know if you read it or not or heard it or not, but NASA announced that they are going to conduct a study about the very real possibility in 2 years of sending astronauts on SLS and do a Mars flyby. They're just conducting the study. They didn't commit to it 100% yet, but I'm sorry, moon flyby, not a Mars flyby. What do you think? That got your attention, didn't it? A moon flyby in 2 years with astronauts on SLS. But what do you think of that idea? What do you think we could be doing in the next 4 to 8 years?
Mr. Chairman, the one thing, again, is continuity and adequate management and budget resources. And it's so important, I think, that people understand why we need a big booster. And for the new members of the committees here to emphasize that when I lifted off to go to the moon, and when Jack Schmitt lifted off, the total mass was about 6.25 million pounds. And in 11 minutes, we put approximately 300,000 pounds into orbit. I had about 138 metric tons, and Dr. Schmitt had a little bit more on his. And then we kicked out. And on the way then most of it was a third stage with the fuel in it. The useful pay, which was about 4.8%, only 4.8% of that giant booster. And what was the useful payload, the lunar module and the command module, was a third of that. So we had 1.6% that went on to do that mission, to land on the moon. So this is why you need a big booster. You'll see all different ideas. We'll take small ones and put them together and all this. Well, we've been through it and say we've studied it from A to Z. Doesn't work. Okay. We're started down the right path, and I think.
Good to hear. Okay, thank you, General Stafford. And Dr. Stofan, you have a special interest in discovering life in the universe elsewhere outside of our solar system, and I have a special interest in that as well. I think it's a fascinating subject. What are the prospects of discovering some form of life, vegetative, sentient, whatever it might be, elsewhere in the universe outside our solar system? And do we have any hope, say, in the next 10 years with any of our telescopes or next-generation telescopes of picking up spectra from an Earth-like planet, for example?
Well, as you know, we have all of the targets from Kepler of planets around other stars, some of which lie in the habitable zone. And then obviously we have the transiting, TESS, the Transiting Exoplanet Survey telescope that will launch in about 1.5 years that will, we think, find a habitable planet, a potentially habitable planet, about one a month. for its 3-year mission. That means we're going to have a lot of candidates for the James Webb Space Telescope, which has the ability to look at the atmospheres of planets around other stars. So James Webb will hopefully start looking for gases like carbon dioxide, methane, oxygen, water, that would be potentially indicative of habitability. But it's really going to take that next generation of space telescope, I think, to get us from identifying potentially habitable worlds to being a lot more confident that that world is actually potentially inhabited. So for right now, I think our focus really needs to be on our own solar system, Mars, Europa, Enceladus, Titan, where we can really push this question of what are the bounds of habitability, what are the chances of life beyond Earth by really looking at our own solar system.
Right, and as you know, NASA has plans for Europa as well, too.
Yes.
With the indulgence of my colleagues, let me squeeze in one last question for Mr. Young, and it is this. Mr. Young, you mentioned the constraints of the budget. You said we have limited resources, all of which is true. So therefore, what can NASA do best? What can the private sector do best in order to maximize the use of our resources?
I have a couple answers to your question, which is a very good one. First off, I really believe we've got.
Will you pull the mic towards you just a little bit? Thank you.
Okay.
There.
I really believe we've got to make the hard decisions. We cannot distribute the limited budget over all of the possibilities that exist, even though they all have merits, and expect to accomplish them all. So we've really got to establish priorities, number one. The second thing is that having spent a bit of my life both in NASA and also in the private sector, I have some appreciation for both sides of the equation. NASA has enormous, what I call continuity of capability. To apply to a given space exploration kind of an endeavor. Industry goes much more from project to project and has enormous implementation capability. And I think we need to recognize what the strengths that both groups bring to this particular problem. And when we're able to marry the enormous continuity of capability that NASA has and the implementation capability that industry has, we seem to really be able to accomplish an awful lot. When we choose to tie one or the other, one of their hands behind them and say, look, we're only going to use part of your capabilities, that's when we usually end up with not very satisfactory results.
Okay. Thank you, Mr. Young. That concludes my questioning, and I'll recognize